welcome back to our course. So for this topic, this is the NumPy part 2. So we will be discussing about the following. So NumPy array indexing and selection. We have indexing a two-dimensional array or the matrix. We also have selecting conditional selections. And of course, we have the matrix operation. So we'll review the matrix operation here. I hope you still remember your linear algebra. So we've been hitting here your talent and skills in linear algebra. So for the first section, so we will be selecting and indexing a NumPy array. So if you're familiar with a list, this is just similar to list. So from now on, we're going to create an array. So we will not be using any more piping it into list. So we'll go directly. So again, before you can use the NumPy array, you must import the library. So the code is import NumPy as np. So we'll be sticking with np here. Okay. So the next one, we create a array. So let's denote as new r, equivalent to np dot arrange. So not arrange the double r, so only singular r. Then we create let's say an array range from 0 to 15. So again, 16 is exclusive. So shift enter. So let's confirm our new array. So array. Okay, so we have from 0 to 15, but we have 16 items on the array. Okay, so how do you index this? So if you're familiar with a list, you still use the indexing notation. How about we index here the item 9? So we just use new array 9 and alt enter. So that is for a selection for singular item on the array. But how about we have sections of array that we want to select? Say for example, we want to select this from 1 to 5. So what will be the syntax? So again, we have a new r. So we will use the colon notation here. So if I want to select from 1 to 6, I will start at index 1. If I want to select 1 to 6 or 1 to 5, so let's decide. So we select 1 to 5. So I will select from index 1 to index 6. So that will be an array from 1 to 5. Okay? So how about I want to select from 0 to 9. So what will be my notation? So new r is 0. If we count that, so 0 to 10. Okay, so I'll enter. So we've selected 0 to 9. Okay, so again 10 is exclusive. So to save some typing, so we can also use this. So if you remove the first index, so it means it also means to start from the beginning. Okay, so we execute this one. So shift enter. So from 0 to 9. Okay, so about we select from 5 onwards. So item 5 onwards. So again, so new array. Okay, so how about 5 then onwards? So if you leave the second parameter blank, it means that from 5 you're selecting onwards. Okay, so Alt Enter. So we have 5 selecting until 15. Okay, so another important thing to remember is NumPy arrays has the ability to broadcast. So let me demonstrate it to you. So how about we have a new array? Then I want, for example, from index 0 to 7. So I will have a specific value, let's say for example 100. So let's execute this one. So what will be the new result of our array? So new array, if I want to see the value of the new array. So look at this one. So from 0 to 7, from index 0 to 7, I have replaced value. Okay, so 0, 1, 2, 3, 4, 5, 6, 7. But again, 7 is exclusive, so it's only from 0 to 6. So let's compare that with a list. So for example, I have a list of 1, 2, 3, 4, 5. Okay, let's execute that one. So about LST from 0 to 3. So I want to replace the value to 100. Okay, so Alt Enter. So this is the big difference between an array and a list. So again, let me have a comment here. So NumPy arrays has the ability to broadcast. So this is called broadcasting. So while the list cannot broadcast. So that's the difference. So look at here, from 0 to 7, I easily replaced the specific value of 100. So everybody is affected. But when using a list, such as this one from 0 to 3, it says can only assign an iterable. So this cannot be, the broadcasting cannot be done when you are using a list. That's why array are much more flexible than list. But list has its usage, so don't underestimate list. So definitely arrays are much more powerful in terms of data science. So let's move on from indexing a 2D array. So let's save first. So up to this point, we're only creating a single vector. If you notice, it has only one dimension. But when you are analyzing data, so usually it has multiple dimensions like column and rows. So it's important also that we learn how to index a 2D array. Okay, so let's create a 2D array. So let's create one. So array, we have, let's name it 2D. It's equivalent to NP array. So again, so we used, how about we use list? Then we'll reshape it. So 2, 4, 6. Okay, so we have 8, 10, 12, 14, 16, then 18. Okay, so Alt Enter. So let's see what our 2D array looks like. So this is a 2D, but it's not a 2D array. Okay, it's not yet a 2D array. So you can also do this. Okay, so let's replace that. So array 2D, so same, it's equivalent to array 2D. Okay, then how about we reshape? So since this is a composed of 9 items, so we can do reshaping into 3 by 3. Okay, so Alt Enter. So let's see what is our array 2D now. So that's the difference now. So we have 3 columns, 3 rows, I mean, and then we have 3 columns. So this is a multi-dimensional array. So we can also say that it is already a matrix. So it is a multi-dimensional. Again, it is denoted by another square bracket outside. If you notice, we have two now. So this is a multi-dimensional array. So the first question is, how can you grab items from this list? Okay. So how will you grab? So how about what if I ask you to grab the value of 2? So again, these are multi-dimension. These are not a single vector anymore. So again, if you're familiar again with indexing with list and array previously, so the concept is similar, but there are minor changes. So how can I grab array 2 here? Okay, so let me annotate. So again, you want to use annotation on your web page, you can use annotate.net. This is a Chrome extension. Okay, so I will annotate. So let's count the number of rows. So again, we have so 1, this is 0. Again, it start with 0. 0, 1, 2. Then in terms ng column, so 0, 1, 2. Okay, so how can we grab this number to here? Okay, so that's index 0, 0. Again, we have the row column notation. So first we select the row, then the second item we select the column. Okay, so let me erase this one and let me type. Okay, so we'll be doing here array 2D. So we're having the index of 0, then 0. So Alt Enter. So we are grabbing the number 2 here. So we can also use this as a shortcut. So this is to save additional characters. So we can also do this. So that this is the comma notation. So Alt Enter. So same. So whichever you prefer. So you prefer multiple square brackets, but I prefer the comma notation when in terms of indexing multi-dimensional array. So again, Alt Enter. Okay. So about we grab the first row. So what will be the syntax here? So if you want to grab the first row, so you can say array 2D. So you grab the first row, then I think this is enough. If you type array 2D 0, you're grabbing the first row. So Alt Enter. I'm sorry about that. So Alt Enter. So you are grabbing the first row here. So 2, 4, 6. Okay, so no need for another the second notation. Okay, so how about you grab the specific sections of the array? So for example, you want to grab 16. Okay, let's grab first a single item again. So grab the value of 16. So for example, so what will be the notation? So we can say that it is array 2D again. Then we have 2. Okay, so we can find the 16 at row 2. So 0, 1, 2. Okay, then we can find the 16 at the index 1 column. Okay, so Shift Enter. So we're grabbing the number 16. Okay, so I will repeat. So first, the first one is the row, the second one is the column. Okay, so 0, 1, 2. So if you type 2 without the 1, you're grabbing the last row. Then since you're grabbing the last row, Then the second one is the column. So last row, column 1. So actually we're grabbing here 16. Okay. So you practice this at your own. But the concept here is still the same. If you have the idea of indexing list and also string. So it has similarity, but now we're working here at a two-dimensional array. So we're working at 2 parameters here. Okay. So how about more example? So how about selecting sub matrices? So for example, okay. So how about you select this one? So selecting sub matrices. Okay. So how about I'm interested with the value of let's say 4 and 6, and I'm interested with 10 and 12. Okay, so again let me display again the structure of our array 2D. Okay, so I want to grab this one. So let me annotate so you can see what I'm talking about of what we're trying to grab the value. So I want you to grab this one, this portion, this section of an array. So how will you grab this one? Okay, so again you count. So this is index 0, index 1 in terms of row. So this is index 1, yes, index 1, and this is index 2 in terms of column. So if you want to grab this one, so our first number here is you start from the beginning by denoting a blank. Then you will end up with 2 again. This is exclusive. Okay. Then for the column, you start with 1 and you grab onwards. So this will be the index. So again, I will write this bigger. Okay. So blank, colon, so 2. We're using the comma notation. So 1, not 1, comma, sorry. So 1, colon, then square bracket. Okay. So let's try to execute this one. So let me erase this one. Okay. So that's our notation. So for example, array 2D. So start from the beginning, end with second column, exclusive. Then from the first index of the column, so grab onwards. So shift, let me out enter. So we're grabbing here 4, 6, 10, 12. So correct. So 4, 6, 10, 12. So this one is 4, 6, 10, 12. Okay. So more exercises if you want. So how about, let me just copy this so I won't be typing a lot. So first, so how about we grab the value of 8, 10, and 14, and 16. So we want to grab this one. So 8, 10, 14, and 16. Okay. So how? So again, let me annotate. So I want to grab this one. So I want to grab this portion of the matrix. Okay. So what will be the index? Okay. So again, so 0, so 1, 2. So I want to start with 1. Okay. So in terms of row, so 1 onwards. Okay. In terms of column, so I want to start from 0, but I want to end with 1. So again, 2 is exclusive, so this will be the notation. Or you can remove this one. So to simplify, our notation is 1 colon, then comma, then blank. So this is colon, this is 2. So you will be grabbing this one. So 8, 10, 14, and 16. Okay, so let me clear the screen. Okay, so 1 and 2. So let me not clear first, so I won't forget the indexing. So let's execute this here. Okay, so we have array 2D. So column 1 onwards and blank, and column 2. So we'll be grabbing here 8, 10, 14, and 16. So another one, just to practice. So let me copy this one. So copy. So let me paste here. So let's alt enter so that additional rows will be created. And I want to delete this now. Okay. So you press clear all annotations. Okay, so how about I want to select this specific sections. How about 2, 6, we have 8, 12, and I also want, for example, 14 and 18. So again, let me execute the array 2D, so that I will see the value. Okay, so I want to select I'm sorry, I'm not selecting here the I'm selecting, because this one are separate. Okay, so 4, 4, 6, 10, 12, then 16, 18. Okay, so I want this one. So I want 4, 6, 10, 12, 16, and 18. So what will be the index? So array 2D again. So I want to grab this one. So I want to grab all the rows. Then from starting from 1, I want to grab onwards. Okay, this just means that grab every row. The second after the comma means that start from the first column, then grab everything. Okay, so shift enter. So that's 4, 6, 10, 12, 16, 18. So at first, this might be difficult for you. So rewatch again the video. I know you will get this. So that's it. That is how we select sub matrices. So do you want more example? Okay. So last one probably. So copy. So I'll paste this one. So how about we select this one? So 8, 10, 12, about 14, 16, and 18. So again, let me execute the array2d. Okay, so I want to grab this 8, 10, 12, and 14, 16, and 18. Okay, so how? So again, you type the array. So array2d is equivalent to. So you want to grab the first and second column. Okay, so the equivalent here is you start from 1, then onwards. Okay, then for the column, you grab all from 0 onwards. So this one is 8, 10, 12, 14, 16, 18. Okay, so we're so far so good. So we're able to select the portion of the matrix. Okay, so I want you to practice this one. Okay, I will not demonstrate it. But what if I have a big array? Okay, so so I will make an example of this one. So how about I create another 2D array? So let's name this big 2D array equals, how about NP? So let me generate a number. So from range of, I want to generate 50 numbers. Then I want to reshape this generated from 0 to 49 numbers, which is 50 items, to 5 by 10 matrix. So 5 times 10 is 50. So we can reshape this one. So again, shift enter. So let's see what will be the structure of the big 2D array. Okay, so this one. Okay, so how about you grab this one? So let me annotate first. Okay, so for a big 2D array, so what if I want you to grab this specific portion? Okay, so 23, 33, 24, 25, 26, 27, 33 to 37. Okay, so again, if you're having trouble indexing, okay, it's okay to count. So, okay, so this one is 0. So 1, 2, 3, 4. So we have a lot of column. So we have 10. So 0, 1, 2, 3. So let me just write here 3, 4, 5, 6, 7. Okay, this is 7, index 7. So we're starting from 0. So what will be the notation here? So our notation here is to start from 2, okay, then to end with 4, okay, exclusive. So comma, we start from 3 and we end up in 8, okay, this one, index 8. So we end up in 8, then we end up in 4. Again, this is exclusive, so not included. So if we execute the code, I hope we are correct. So big 2D array. So we have notation of 2 colon 4. Then we have 3 colon 8. So shift enter. So let me fix the annotation. So 23, 24, 33 to 37. So we are grabbing the sections of matrix here. So that is correct. So let me close this one and clear the annotation. And let me save first. So save. So for the next section, we'll be doing a conditional selection. You can also do a conditional selection in NumPy array. So to demonstrate, let me create another array. So another array. So let's use NumPy. So NumPy denoted by NP. So arrange. So let me create a numbers from, let's say, 1 to 15. Okay, shift enter. So let's see the structure. So another array. So we have number from 1 to 15. So we can do this one. Conditional array means we have greater than, not equal to, just like the comparison operator. So let's see. So another array, how about I want only less than 5. Okay, so this will be the result. It returns a Boolean values. So as you can see, another array less than 5. So is 1 less than 5? So no. Is 2 less than 5? No. 3 less than 5? No. Is 5 less than 5? Another no. Is 6 less than 5? Is 6 less than 5? Okay. So this true. Okay. So we have a false, false, false. So we have another array is greater than, I'm not I'm not saying less than. Actually, this is a greater than sign. Sorry. So is 1 greater than 5? Is 2 greater than 5? Is 3 greater than 5? Is 4 greater than 5? Sorry about that. I thought this was a less than sign. Okay. So the first 1, 2, 3, 4, 5, 5 is of course will result to false. So 6 is greater than 6. Okay, so these are conditional selection. So what if I want to return only the value that met the certain condition? So what we'll do, the long way is to assign this into a Boolean array, for example. So another array is less than 5. So for example, So if we want to see the Boolean array, so basically it's just the same. Okay, but we're assigning here Boolean array. So in order to filter out the specific value, so you can do this. You assign the Boolean array as the index for the another array. So for example, I will alt enter. So all that is greater than 5 are being grabbed. So this is a long way. Actually, you can do this. So another array, you type the condition inside the square bracket. So it's just the same. So this, I prefer this one. It's just a shortcut. So it's the same. So 6, 7, 8, 9, 10. So you can do a conditional selection in a NumPy array if you have a certain condition, not just number but also text string values. So, but in data science, we are more concerned on numerical values. Although there are categorical values too, but usually it's more on numerical. Okay, so that's for conditional array. So if you still remember your matrix operation, you can add, subtract, you can do scalar multiplication, matrix multiplication, the dot product. So division in matrix operation, there's no such thing. So we can do theoretically division, but it's not really a division of matrix. So for example, let me have a addition of matrix. So for example, we create the matrix A and B. For example, A is equivalent to, let's see, how about NP array. So we have, for the first array, we have 3, -4, 8, and 5. So let's reshape this one to make it a multidimensional array or matrix. Okay, so B, let's say NP array. We have the values of 9, -5, 2, and -6. So we also reshape this into 2 by 2 array. Okay, so alt enter. So we have a certain error. I forgot the parenthesis. Of course, this is a function or a method. Okay, so we have an error here. So shift enter. Okay, so this is A, so two-dimensional array. This is B. So this is a 2 by 2 matrix. So both are 2 by 2 matrix. So we can do addition in NumPy. So remember, you can only add matrices if they have the same dimension. So we have 2 by 2 dimension. If one is only 1 by 1, so we cannot theoretically add. But Python does the addition even though it has not uniform size. But theoretically, you can only add matrices if they have same dimensions. Okay, so you should do this. So np dot addition. Okay, so it's a part of a method of NumPy. So you pass the matrices here. So np addition. So will result. Oh, I'm sorry. NumPy has no addition. I mean add. Okay, so alt enter. So that's 12. Okay, so if I annotate this one, so basically it just add the specific rows and columns. So you add 3, 9, so that's 12. Okay, you add 4 and -4 plus -5, so it will result in -9. So in terms of subtraction, it's the same. Okay, so how about we do this np dot subtract. So A and B, you pass the matrix. So it's just the same. So let me annotate so that you would understand more. So 3 minus 9. So that's negative 6. Okay. So negative 4 minus negative 5 will result in negative 4 plus 5. So this is 1. Okay, so you get the idea. So that's how you perform a matrix addition and subtraction. Okay, so let me clear this one. Let me save first. To save. So before we continue with multiplication, so let me emphasize that we cannot add matrices with different dimensions. So let me create here a C NumPy array. So let's do this one. So for example, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9. So we can reshape this one into 3 by 3. Okay. So shift enter. So this is A. So this is B. So how about we have C here? So let me just display the value of C. So we have 3 by 3. So what if we add A and C? Okay. So what if we add A and C? So np dot add. So you would like to add A and C. So what will be the result? So again, it will result in error because I told you earlier that in array addition and array subtraction, you can only add if two matrices have the same shape or they have the same dimensions. Okay, so this one is a 3 by 3 matrix. Okay, the letter C, while the A is a 2 by 2 matrix, so you cannot add. Okay, so let me comment this. Cannot add matrix if dimensions are not the same. Okay, or the shape. This one, the shape. One is 3 by 3 and one is 2 by 2. Okay, so let's go to what's next. So scalar multiplication. So we can also multiply here in multiply matrices. So what scalar multiplication means is this one. So for example, let me annotate that this one. So scalar multiplication means you have a k, for example, you multiplied with item, so a1, a2, so a3. This is just an example, so a4. Okay, so we just distribute the specific value, the array. So that is called a scalar multiplication. Okay, so why I am multiplication? Sorry, bad at spelling. So why am I teaching this one? So we will encounter this one when we are analyzing data. Okay, so especially the multiplication part. So let me erase this one. So what if we have scalar data? For example, I want to multiply our matrix C with the number 3 or the matrix A, just to be short. Okay, so we can do this. So numpy dot multiply. So 3. So that's our constant. Okay, so shift enter. So we just multiply this one by 3. So this is 3 times 3 is 9. Negative 4 times 3 is negative 12. 8 times 3 is 24. Then 5 times 3 is 15. So that is scalar multiplication. Okay. So we also have matrix multiplication. So matrix multiplication behaves differently. So let me review you in terms of how to multiply uh, matrices. So for example, So what if we have two matrix with different dimensions? So let's take for example just a simple example. So for example, we have a 1 2 and a 1 2 matrix. So this one is a 1 by 2 matrix. Okay, the other one is a 2 by 1 matrix. So again, let's see if we can make this into multiplication. So yes, so if the two inner portion of the notation signifies that this equals, we can multiply this one. So what is surprising here is that the result is a 1 by 1 matrix. So the result is a 1 by 1 matrix only. So we are expecting this is a single number inside the matrix. So again, so how do you perform multiplication on different dimension? This has a different dimension, but they have the same number amount of items. So this one is if you index this one, so this is 1. This is 1 2. So this is 1 and 2. So this is 1. So what you're going to do is to multiply this one. So 1 and 1. So 1 and 1. So the result will be, so 1 times 1. Okay. So you multiply the next one with another this one. So 1 by 2. Okay. So multiply by 1 by 2. So this is 1 by 2. So we have plus. Okay. So we have plus 2 times 2. Okay. So we have 4. So the answer is 5. 5 only. So for multiplication of two matrices, so the answer will be 5. So let's confirm that. Okay. So by the way, we're not using here multiply because we are getting the sum of the products of the item in the matrix. So if this is the case, we will use the dot, not the multiply. So for example, let me define first the array of 1 2, both 1 2. So let's define it as R. So np dot array. So we have 1 2. So this is the first array. So another one s. So np dot array. So again same. So 1 2. But this time we will reshape this one into, let's see. So the shape of this one is a 2 by 1. So Alt enter. Okay. So we will produce NumPy. So instead of multiply, okay, so we will use the dot. Okay. So the dot is R and S. So I'm expecting this will be 5. So this is the correct answer. So we will not using the multiply. Why? So we will give a wrong answer. So we use the multiply. So R and S. Okay. So we will just basically multiply the item. So this is not the correct answer. So we will use the dot. So once the sum of product happens in this one, so usually we have done this because according to our notation, the result is just only a 1 by 1 array. So we will result to a dot product. So this one is wrong. Okay. So let me delete this one. So the correct answer is 5. So as confirmed. Okay, so we will use this 5. So if you see this, that's our final answer. So that is 5. So let me erase. Hope you're understanding me. So this is just a linear algebra. So I'll give you another example. So let me just clear this one. Okay. So let me have another example. So another one. So what if we have this set of matrices? Okay, so how about we have this one? So 1, 3, 5. Okay, that's our first matrix. Then we have this one. So we have 1, 3, 5, 2, 4, and 6. So what will be the result? Okay, so first let's identify the dimension. This is a 1 by 3. Okay, this is 1 by 3. So the other one is a 1, 2, 3 is a 3 by 2 matrix. So again, so we can perform multiplication. We have the same. So we're expecting the answer to be 1 by 2 array. So we're expecting this result. Okay, so one column, we have two answers here. Okay, so how can we derive this one? Okay, so again, you denote this one if you are confused. So this is 1, 1, 2, 3. Okay, so this is 1, 2, 3. This is 1, so this is 2. Basically, we're multiplying this one to this one. Okay, so what will be the result? So the result will be, I will denote this as the blue one. So we have 1 times 1. Okay, so 1, 1. So we have 1 times 1. Okay, so next is 1 and 2. So plus, we have 3 times 3. Okay, so we have next as plus 5 times 5. Okay, so that will be our first item. Okay, so another one, we have 1 times 2. Okay, so plus, let's shortcut this one. So 3 times 4 is 12. Okay, then 5 times 6 is 30. So we try to add. So 1 plus 9, so is 10 plus 25. So this one will be 35. Okay, so this is 2 plus 12 plus 30. So this one is 42. 42 already. So this one is 44. So again, a dot product happened here. Okay, so instead of multiplication, we'll be using the dot. Okay, so the answer is 3544. So let us see if I'm correct. I hope so. So let us denote this one. Okay, so let me enter a lot of space. Okay, so let's denote how about F equivalent to NP array. So we have here 1, 3, and 5. Okay, so G, so NP array. So we have here 1, 3, 5. No, sorry. So we have 1, 2, 3, 4, 5, 6. Then we will reshape this one into 3 by 2. Okay, so Alt Enter. So wow, now we have not wow. Now we have NP. So dot. So we have FG. So Alt Enter. So we have 35 and 44. So we confirm that this is the correct answer. Okay, so again to confirm this one. Okay, so 35, 44. So our result will be 35, 44 also. Okay, so do you want another example? Okay, so one last example. So let me clear this one. So another example. So how about this one? So how about another example? Okay, so what if we have this one? So let me write this here. What if we have 1, 2, 3, 4, 5, and 3? Okay, so this is our first matrix. So the other matrix will be 2, 6, 4, and 8. So this one is a 3 by 2. Okay, so this one is a 2 by 2. So to check if we can multiply, so it's the same. Okay, so we can. So our resulting answer will be a 3 by 2 matrix. So this will be the pattern for the answers. So we have 1, 2, 3, and we have 2 columns. Okay, so how can we solve that one? So I will just write here at the top. So we first let me number this one so that you won't be confused. Okay, so this is 1, 2, so this is 1, 2. Basically, we multiply this one with this one, then this one with this one. So another one, we multiply this one with this one, and this one with this one. Okay, so to make it clear, I hope it's making sense. Okay, so let's do the operation. Okay, so 1 is 1, so 1 times 2, then we have plus, so we have 2 times 4, so we have 2 times 4, so this is the first one. Okay, for that, so we have 1 times 6, and 1 times 6 is 1, and we have 2 times 8 plus 2 times 8. Okay, so that's the first set. So we have here 3 times 2. Okay, so 3 times 2. So plus, we have 4 times 4. Okay, so next one. So we have 3 times 6. So 3 times 6. Okay, so plus 4 times 8. So we have here 4 times 8. So I'm running out of real estate space. So let me just finish this one. So this one is 5 times 2. Okay, so 5 times 2. So plus, so I'll overwrite this one. Okay, so plus 3 times, I think 4. Okay, so the last set will be 5 times 6. Okay, so plus 3 times. So what will be the result of this one? So this one will be 10. Okay, so this one will be 16 plus 6 will be 22. Okay, so 5 times 2, 12 plus 10 will be 22 also. This one is 22. Okay, so this one is 16 plus 6. Okay, so this will be 22. So this will be 18 plus 32. So 18 plus 32 is 50. Okay, so this is 30 plus 24. This one will be 54. So for our answer, so this one will be 10, 22, 22, 10, 22, so 50 and 54. So let us confirm that. So we will using now the dot. Why? Because we result in a sum of product. Okay. So let me just execute this one. I hope you're seeing this one. Okay. So let's define, for example, a U is equivalent to NP array. Okay. So we have NP array. Let's construct the array, the matrix. So 1, 2, 3, 4, 5, and 3. Okay, I'm not seeing this one. So let me just create another line. So Alt Enter. Okay, so that we can still see the answer here. Okay, so 1, 2, 3, 4, 5, 3. Then we reshape this one. So we reshape, which is 3 by 2. So let's define another one, denote by V. So this one is a 2 by 2 matrix. So 2, 6, 4, 8. So we're confirming this. So reshape, for example. So we have a 2 by 2. So I'll enter. So we will not use multiply. Instead, we will use dot because it resulted in sum of product. So np dot dot. Okay, so u and v. So I hope the answer is 10, 22, 22, 50, 22, 54. So yes, that's the answer. So the multiplication, when we multiply this set of different dimension of matrix, will result in, of course, 10. So we have 10. So we have 22. So we have 22, 50, 22, 54. So for our next lecture, so hopefully, so I will end this portion of lecture is getting longer and longer. Okay. So probably for the next lecture, we will have more example of matrix multiplication. Let's try about big sets of matrix like 3 by 4 or probably 5. So see you in the next lecture. Let's have some more exercises of matrix multiplications on how to identify if we will use multiply or we will use the dot. Thank you very much and see you on the next lecture.